Thank you for hanging in there. And we asked all of the moderators of the panels to participate in this wrap up. And we don't want to just repeat information or ideas necessarily that you've heard all week long. We understand that if you're still here today, you've been here the entire conference. So what we want to do is introduce some individual nuggets of takeaways. We want to talk about the moderators' panels, but also things that they heard from other panels and other technical talks that are insightful and informative. So the first question I have, and we can go down the line at our leisure. We've all been introduced already, so don't worry about that. But first question is, like I just mentioned, what is something new or notable that you heard this week? And again, either from your panel or from another session at ISART.
So from my perspective on measurements, especially, so everyone agrees that we need many more measurements that we have. Measurements are critically important to clarify this problem on clutter. And they are also highly depending on the use case. This is another point of agreement. So that, to me, leads to a potential gap, which I personally interpret as both a positive and a negative. On the negative side, so just to describe what it is, so most of the measurements that have been described, they're being going right now, which, as we agreed, they are not sufficient. They are targeted to drive test measurements, okay? So essentially, the drive test measurement, you have one transmitter at some height and then a receiver point with the reception equipment and calibrated that. It's on a mobile at antenna height 1.5 2 meters above the ground, essentially below clutter. So the model, the use case that addresses is one point of the path is above clutter, the other point is below clutter. In fact, I think many organizations in this room, their use case is not this one, it's a different one. The use case is where both ends of the path are at or above the clutter line. The measurements for that use case are much more difficult, as was mentioned, okay, because it involves raising your antenna for measurements at a much higher level, and they are not being done, or very little of it. So I see that as a gap, so that's the negative. The positive side, once we identify it, it becomes an opportunity for more work, more research, and once we have that data, it's going to be very valuable in modeling the use cases for high interest for us. Thank you.
Next. I guess I'll springboard off of that the measurements theme. I also was impressed by how important measurements are, how, especially for clutter, measuring clutter as a source of validation or even a model itself was almost universally accepted. There is consensus on that to a large extent. But one of the insights that I got from the panel that I was on was that we had we had Andy Clegg from Google and we had Niti Tandon, right? And both from the commercial sector, both putting 5G and beyond G into a shared environment, and both dependent on measurements. And then when you dug a layer deeper, on the one hand, for the CBRS case, which was the Google's interest area and use case, if you will, they were using the measurements to be able to determine how much we can compress, recognizing that clutter has value in mitigating interference by basically attenuating interference. How much can we reduce one side of that distribution, if you will, that indicates that there's going to be much higher signals of interference, in other words, lower propagation, by trying to get more and more realistic on that side of the distribution. When we spoke with the Niti and the AT&T folks, the answer to how do you use it was, well, we use it to engineer our wireless networks. We look at the other side of that distribution. We use it to make sure that our signal strength is strong and reliable. So you're looking to look at the side of the distribution and the clutter effects and say, how weak can that signal get? And of course, some of the interesting work is done near the tails or in the tails of those distributions. And yet they look at completely different parts of it in their use case. And the reason it works out that way is, I think, as became obvious with the recent announcement that when you do get the clutter introduced as an additional loss factor, you do get smaller protection areas for the CBRS kind of use deployments. But in the case of AT&T, they use that other part of the clutter distribution to engineer their systems as robust as possible, so that it gives them more flexibility to manage interference by managing other aspects of the network, perhaps with other parameters, even other channels, other MIMO. I don't know exactly how they do it. So it was very interesting that even though they both depend on measurements, distributions of those measurements are very important, and yet they use them in completely different ways, completely different use cases. That was an interesting insight to me.
All right, I'm
going to start with something that it may sound a little bit weird, but I think if you take the question in pursuit of the consensus of clutter, I would declare that in some limited sense, we're already there. We've been there. And I'm going to also reference a comment that Needy Tandon made in her panel with Kalle, that when you actually get down to, you put two technical teams in the room and you actually start, aligning your parameters and aligning your assumptions, there's really generally not that much disagreement. Now, granted, we also recognize in several places throughout the conference that you really need to pay attention that the clutter models, clutter measurements, clutter everything it's random, right? It's a random process. There's a lot of variability, and if you're talking about measurements, there's also a lot of uncertainty. So if you're going to say, well, one person has a median of X, another has a median of Y, that doesn't necessarily mean that you don't have consensus. It just means you have to drill a little bit deeper and look at the actual distributions behind those, and to see what you may actually be in agreement, even though you think that you're not, or you already have consensus, even though you're not. So I have several other stuff, but in terms of the number one thing is, I don't think we're nearly as far apart as anyone might imagine. I do think that when building consensus on what are the right set of parameters or what are the right set of assumptions, there probably is some more substantive disagreement. But technically speaking, I don't think there's really that much. So that would be my number one takeaway.
Go ahead.
Can I be an overachiever and offer two takeaways?
Of course,
It's in my nature. So the first takeaway, when I was invited to be involved in this conference, I really was uneasy because as I stated, I have no expertise, no experience with clutter. I really found that tutorial helped me. It was framed in such a way that I felt like I actually had a lot of understanding of clutter because it was framed as a curve fitting. You take the data and do a certain type of curve fit. So that was really eye-opening to me, that maybe it's not so hard to get involved and make contributions if you have the right tools in place. That's one takeaway. Second takeaway, in our panel specifically, we had a pretty diverse group. We had a lot of different perspectives, but by and large, it seems like the consensus was with regard to openness, collaboration, and growing the community. We're pretty well aligned that those are all key features. And so far, we're grading out pretty well in terms of some of the accomplishments in CBRS and PathSS and the test beds and hopefully centers. But we still have some work to do. So that was really helpful for me to walk away with that perspective and take that back to our team.
So one of the things I found interesting, and I guess as a takeaway, is, so I think I partially agree with Tony's comment that there is some consensus on baseline understanding of clutter, or we feel like we collectively have our hands around the problem or arms around it. What I actually found more surprising as a takeaway is that there was a lot more questions on the data layer of that, the environmental data. I was surprised how many different people, because I'd mentioned LiDAR data before and surface models and stuff, didn't know the LiDAR data was available, didn't have any experience or didn't know how to use it or ingest it or what was important. We had discussions on the modeling panel, vector shapefile data versus other sorts of data, vegetation or not. And it was interesting throughout these past couple of days, it made me think that actually, maybe one of the takeaways is essentially trying to raise the floor and baseline the problem better as a common foundation of what's available to build off of might be a next step. And I mean, we're working on the clutter problem, and we're going to talk about that more, and that's going to continue. But maybe there's also a need to essentially level the playing field, if you want to say, across the different organizations that are actually ingesting and interpreting this data, because I talk about some things other people know. I am 100% sure there are many of you out there that are doing things that I don't know about as well. And so in a way, we're all partially handicapping ourselves in such of our view of what's available. It kind of gets to your talk about tooling, but on the environmental data side. And we haven't even talked, this is just on clutter, we haven't even talked about atmospherics and those sorts of things, which is a whole nother dimension to the problem. But I guess that was one of my takeaways, is that maybe there's a need to have some sort of group together and kind of talk about these kind of fundamental baselines that we sometimes talk at a high level or we take for granted. But actually, if you just scratch the surface a little, there's some we're maybe talking past each other, or where you don't actually doing the exact same things, we're interpreting things differently. And I'm not saying one way is right or wrong or anything like that, but just kind of getting on a common playing field to build off of may help kind of inject some additional value into the work we're doing.
All right, don't be bashful. If you've got comments on somebody else's takeaway, or if it's some thoughts, feel free.
I agree with Tony.
All right, agreement's getting boring. Consensus is getting a little bit boring. No, and I also want audience engagement as well. If you're thinking about, you came up or you heard something notable, especially cross-disciplinary, that to me is one of the most interesting things. It's like we're all describing, an elephant up here in a way, and it's a process of discovery and of communication. Is there anybody in the audience who is this spurring anything or anything you want to add to this conversation? Because it really is a community conversation. It's not just folks up here at a table dictating the truth or what consensus looks like.
Chatting about this at lunch, and I would throw to everybody, to Tony's comment, we have consensus. In a way, we have some consensus. I would agree with that at the high level, and I would agree that to the point that I brought this up to when we were sitting around chatting, that I think we need to move past the comments about let's improve clutter models to decomposing the problem. We understand the problem well enough to really start to decompose it to certain use cases. 8 years ago, it was just, let's wrap our hands around, understand what this beast is. Now it's, I think Kalle brought up, or maybe it was Adrian, when we were talking at lunch. Okay, well, Adrian brought up actually here with the measurement data. What about terminals that are right at the height of the clutter? Like, that's a very specific problem. We should explicitly state that. There's a clear use case. There's a clear kind of framework to frame that problem. Decompose that off the larger thing and say, how do we do that specific thing? How are we going to evaluate that? How are we going to attack that problem? And then there's a directional antenna aspect of this. And really start to narrow in, because we can do that. We understand better what clutter is and how it affects different systems and different use cases. So let's really start to dissect and attack again, decompose the problem. That allows other people to come in and not see this big monolith, or where do I start? We can leverage things that we did with like the tutorial to kind of frame the problem as entries like this is the specific thing we're looking at. But I think we can iterate those things in parallel. We can move forward. We can move the field forward more if we start to break apart specific problems that, specific questions that we're asking, as opposed to let's improve propagation models, and that is I have a better RMSE or some kind of other essentially an aggregate metric. And so I think that's really the next step we need to take as a field, go in that direction.
So it's already been mentioned a couple of times about the measurements, but I think it bears repeating in terms of a pathway towards consensus. So I mentioned a moment ago that we already have, if we actually sit down and align our inputs, as Billy said, we have our arms around the problem, and there's really not that much disagreement. But one of the inputs that we have just so little of relative to what's needed is the measurements, right? And the measurements we have, and as Adrian said and Billy alluded to, they have so much measurement bias in them that it's very difficult in many cases to figure out how to take those measurements and apply them to whatever scenario of interest that we have, right? And so I think that if a pathway, we're looking for what's the way ahead on building more consensus. And one of the easiest things we can do is we can just go out and take a lot more measurements, right? And it was mentioned in one of the panels about taking advantage of signals of opportunity to make some of these measurements. And there really wasn't a follow-up discussion on that, but I was excited that because I've worked on two different efforts where we've looked at ADS-B transmissions from aircraft and GPS signals as a way, because these are ubiquitous transmitters, there's ubiquitous receivers that are all around, and many of them are in a position to actually measure receive power, which gives you an estimate of propagation loss, and many of them are in clutter fields, so to help us build a clutter model. So I think that if we want to get stronger agreement and we want to get stronger models that we can all have consensus around, we're going to need a lot more data. And we're going to need to start looking at beyond drive tests in vans, at 9-meter antennas, driving around in intersections, and trying to figure out what the clutter loss would be, when you're not in the middle of an intersection or with a big antenna van, things like that. So, just as another, if you're looking for that, what do we do next? We go make some more measurements. Oh, and we take measurements that will help us translate the measures, because I mentioned those signals of opportunity, oftentimes they're not in the bands we want, right? The ADS-B is at 1090 megahertz, the GPS is 0135. Those are all lower frequencies. So, but I care about a model in midband or maybe even 7 gigahertz, whatever. So how do I do that? So we need measurements that will help us do that. And we have enough of those and we start to build those. Not only can we build consensus more about the models we have, but then that's also a leg into allowing some of these AI/ML tools. I was the first one to say it, by the way, on this panel anyway. Some of these AI/ML tools and these techniques, without a lot more data, we're going to be severely limited about the power of what we can do there. So, all right, I will jump down now off my soapbox and let somebody else talk.
So to continue for that, yes, data is so important and it's hard to get, and the diversity of data required is enormous. So one important aspect of that, how can we make it accessible to everyone that needs it in order to advance as a community this process? And I want to congratulate ITS for starting sharing their data. That is a great initiative. Now, there are some views expressed here in the last few days that, for example, for private industry organizations, there are good rational reasons why sharing their data may not make a lot of sense. However, I would say that from looking from the other angle, from publicly funded agencies, that should not be the same conditions. So with the right protections in place to ensure privacy and security of protected data and so forth, I think it will be something that all of us, I myself, a government employee, should think how we can advance that and share as much as possible the data sets that we have. That will be benefiting everyone. One more thing to add to this. There was, I think, a comment in the panel this morning that sharing the data, even if you are willing to do it, to share the information and the IP and all that, is actually non-zero cost. There's an operational cost going forwards. There's possible liabilities. There's concerns of that nature that organizations might be kind of worried and mindful when they launch in that process. So there are possible ways, and the one possible avenue to share the data in this realm, study group 3, there is a measurement data bank available on the study group 3 to which administrations around the world are contributing their propagation measurement data. It's fairly limited because, of course, by the time the country submits that goes to the national process, so not everything is being sent. However, it is a way that if someone is concerned about, okay, I want to share this data, but once I do it, I don't want to worry about it. So that's a possible way which can be an avenue mechanism to implement. Thank you. And is for anyone interested, there is data out there that right now it's available for everyone to use. Okay, thank you.
All right, so we've already covered all three of the questions I was going to ask in a way to various degrees, but I want to go back to this one. If you look at the slide, June 10 to 13, what did that period of time here at ISART do to your thinking? Like, how did it change your thinking about where we are, about the future of clutter propagation or consensus building more generally? And I also want to ask the audience too, because I think we all value the back and forth engagement here of, where are we in the pursuit of consensus? Have we achieved consensus? And I think, a few panelists have already mentioned that. And a consensus on what? There's technical, there's policy, there's, underlying assumptions. So how has ISART helped form or advance or progress your thinking on clutter and consensus building?
The last one.
Particularly on our panel, and even though maybe many of us have been thinking about it before, it was really highlighted, and Casey did a good job of talking about the different things that are going on in CBRS, and there was participation from the audience sort of talking about that. One of the barriers traditionally to consensus on clutter was the risk of making a mistake. Right? And in a lot of the early, like I made a comment from the floor, I think the first day, that nobody actually cares about clutter, right? They care about whether or not my system is going to be able to achieve its mission, or am I going to be able to provide service to my customers? Am I going to close the link in my radio? So clutter in that way is a means to an end. And so when you think about choosing the clutter model or consensus, or trying to build consensus on clutter model, you automatically bring in what does that mean? If I agree, or I can have a consensus at this, what does that mean for the real thing that I'm after, whatever that is? And when you have a system where your decisions are forever, then you're very fearful. You don't want to make a mistake, right? Because there's no way later to go, oops, I forgot about this, that, or the other thing, or that data set had a bias that I didn't recognize, and so on and so forth. And you're trying to retract when real money has been spent, or real decisions have been made that are very difficult to undo for whatever reason. But by trying to build the objective tasks, the big tasks that you're trying to do, by building the opportunity to have a refinement or a back and forth. We'll try this, we'll see how well it works, then we'll maybe do something a little bit different. And then if that's not good, then we can come back a little bit or whatever. If you have that going in, again, you're going to get, it's going to be a lot easier to get consensus on a particular clutter model or a particular way of looking at clutter at any one point in time. But if you don't have that, undo or redo or go back built into your process, then it's hard to sometimes close that gap. So,
If you want to press the view towards the future of where we take clutter,
Yeah, how are you viewing the future
right,
after this week?
without getting into a roadmap yet? Is that the?
Well, we definitely want to challenge with next steps, actionable. But yeah, you're thinking about where we are, where we go.
Yeah, I first of all, I think the amount of work that's been focused on this particular issue of clutter with with what I called earlier the up at bat use case, which is the sharing with the radars in the 3 gigahertz range. We focused a lot on that, and I think there's been lots of progress made, and the modeling and the measurement and the identification of the modes and all that is quite interesting, but it's also use case dependent. And when I think about the future that's not that far away, the next, as we put it earlier, in the on-deck circle is 8 gigahertz, 7 and 8 gigahertz. And Greg Wagner from the PO Spectrum Shop asked us to look at some of the issues of dealing with that band. What does it look like? What's in there? Does it change the use case? Does it change the way we even look at clutter and what parts of the clutter we need to worry about? And so we did a little bit of that, and it's a different animal. And I think one of the things that makes sense to start doing is start giving some thought to, it's not like you're not busy enough here, but give a little bit of thought to what makes it different. And why it's different is if you look at I think there's like 14 sub-bands in that range that's been identified in the National Spectrum Strategy for the pipeline plan. It's mostly, I think, dominated by fixed point-to-point or fixed satellite service equipment. And one of the things that, in fact, I gotta give Greg credit for this, he looks at the world to a certain extent as, is it episodic or is it continuous in terms of the use of the frequency? Is it always on, or do you turn it off and on, or does it come and go? And also, is it dynamic or is it static in terms of location? And our use case that we've been solving now and reducing clutter measurements and models to the problem at hand has involved episodic, highly mobile, somewhat dynamic participants, if you will. You take that 7 to 8 gigahertz band, those things are fixed in location, fixed in frequency, continuous operating, high gain antennas, optimally sited, and then if you put all that together and say, okay, does that change our clutter, our approach to clutter, the kinds of measurements that we have to take, the kinds of models we would apply, and opportunistically, the kinds of measurements we could take because there's systems already out there or continuously transmitting, you could listen to them, that kind of thing. And I think it might be time to give a little bit of thought when we think about the future of clutter modeling, about how that affects how we ought to vector ourselves into that next generation of clutter modeling for the use cases that are in that next pipeline band.
No, I would agree, and I think that gets to what you're talking to is really important. That breaking down, really clearly identifying what are the different use cases, prioritizing those, and clearly defining those. That allows people to either gauge on the problem or engage on hey, I want to take measurement data. What specific type of measurement data do we need? What sort of type of experiments? What little bit of this larger problem can I break off and nibble at myself? Whether anything down from a grad student up to a company or a government lab, that I can work on that and contribute to that larger piece of that puzzle. Because yeah, as you said, all the different systems, all the different kind of sub-bands in there, to attack that whole thing can be imposing. And the ability to better frame that and break that down allows things to become more approachable, allows the work. You're essentially paralyzing the problem, right? You're allowing for specialization inside that. Yeah. And I think that will allow us, it was mentioned, I forget who mentioned it, but the timelines are aggressive, right? Like we look at that, we see what the timelines, whether it's in NSS or whether it's with the WRC. It's all really aggressive timelines to get things done. And you're not going to solve it all linearly from the beginning and just one person doing it. So I don't know how you can get there without doing those sorts of approaches.
I think, by the way, the solution sets beyond just getting better at clutter, but a CBRS-like solution may not make sense in some of those completely fixed in all dimensions kinds of environments. It may not make sense. I wouldn't swear to it. Casey may change my mind about that, but But it's something to consider. It goes beyond just clutter. What's different about it?
We have a question? Well, you evoked or invoked Casey's name, so here we go.
Yes, in the middle of the room.
Migrate. Okay. Oh no, right there. Okay. Yeah, I agree, Kelly. Let me- So, kind of piggybacking off of that 7 to 8 gigahertz notion. So, should we start thinking about the problem differently when it comes to studying a band, in the sense of, are we doing things in the wrong order? We're studying a band, then trying to improve the model afterwards. Should we be looking at the availability of good model data of, we understand the environment, so let's use that to then study a band? So should we be focusing on understanding the clutter environment, understanding the propagation environment in a band, and use that to then inform what we should be studying?
I think that's just real quick reaction. I think that makes a lot of sense, especially since it's different. That particular band is different in the very nature of what it, the dynamics of it, and the precision with which, and the stability with which things like antenna patterns are going to stay the same for years. Maybe they'll eventually change, and satellites that are up there, geostationary satellites, they're going to be in the same place for a long time. And so that changes and gives you the opportunity to maybe study those kinds of issues. Is that what you were thinking about?
Well, okay. Yeah, I mean, I think one of the big challenges, like going back to millimeter wave, we went and studied it and then did regulatory proceedings based on it. And then we went and did the modeling and the measurements and found all these challenges after the fact. Should we be flipping that on its head and going, let's measure an environment, let's understand what's going on, and then use that to then inform what we should be studying for regulatory proceedings, sharing studies, et cetera?
You're arguing whether we should fund a government lab to study propagation ahead of time. I would support that notion.
I second that, yes.
I was going to rephrase that question, Eric Nelson, if you're listening. Do you want to opine? Fund ITS to do advanced research.
For sure. 2 points on that. From the government regulator's perspective, it's obviously better for the characteristics of a band to be well understood before they proceed with a proceeding about doing something about it. So that is totally fine. Obviously, there are limited resources to do that, and then the government will come and do a match. And then once those proceedings are starting, then the whole industry at large comes, and there's much more weight brought to bear to the problem, and that things advance. I'm going to refer to the very interesting presentation on the meteorological modeling that we had the other day. And I'm going to link to that when we see that slide with how many models are possible to be applied. Okay, and I think as an engineering perspective, I think it's always better first understand the problem that you want to solve really well. Okay, what are the parameters? You have a new system, you have an incumbent systems, what are the protection criteria, what are the statistics of the services being provided, what are the tolerances that you need to, and then based on all that data, I think ideally you would choose the model that responds to your needs to the best knowledge. Okay, so from the set of models, you should have a number of them and then choose the right one for the use case that you have.
So I'm about 30 minutes behind the conversation, but this ties into Casey's point. One of the things I would say is that there is a stress put on measurements, but also I would say measurement uncertainty is extremely important in this case because lots and lots of bad measurements or measurements with very high variability won't allow you to validate the model anyway. So I just wanted to say that, and maybe it's obvious.
I can speak to that too. So someone made a comment, I think yesterday, that the best variability you can expect from measurement is about 6 dB, which I think that was a great comment. So no measurements are perfect. And in fact, if you think about it, the random variable that is measured itself, it's a random variable, okay? And it's going to be a specific standard deviation. You cannot go below those physical limits. So from that perspective, it is very important to characterize all these data sets as best as we can, and then when you use them, to use those characteristics to qualify. Okay, we always can do statistical processing and then understands the moments of the statistical distributions for the data sets that we have, and then apply them correctly. But it's unavoidable, right? And there will be very expensive data sets which are good quality, and not as expensive, which will not be as good. But I think, given the situation where we are, that we are very short, we should use everything we have. And I think also the consensus point to in the past in the measurement panel was that there's value in all the measurements, okay, but you have to use them carefully, right? Okay, yeah, thanks.
Add to that. I think it's related to that. I think it's very important to be aware of the noise that's in measurements that contributes to certainly to the 6 dB. But sometimes, if that's wishful thinking, if it was that narrow, but sometimes you see measured data that's really wild in terms of the statistical distribution, and but you don't have the information of exactly how the measurements were done to figure out what's going on there. And an example is if you take an omnidirectional probe antenna and you put it in a screen room with all the attributes in a perfectly symmetrical ground plane, yeah, it looks pretty much like an Omni. Then put it on your camping van and all of a sudden things change, right? And it's impossible to tease out that kind of information out of measurements once that's happened.
You can put the whole van in the screen.
Yeah, well, you could, and you could measure the pattern. But if it's a magnetic mount, all someone has to do is bump it, and then you're starting all over again. So I think there's someone earlier in one of the earlier panels talked about documenting the kind of metadata and the kinds of methods that are being used along with the measurement data sets themselves, so that there's thorough scrutiny as to what the nature of the noise is in there. I'm using the term noise loosely here, and the possible sources of errors. They're useful, but some data sets might be more useful than others if you understand and you can have more confidence in exactly what was done and how they were done.
But I would also, you can spin that forward as well, and that does also instigate the question, the thought of, do we need to think more carefully about how we then use the measurements to validate the model, instead of let's run the model against all possible measurements and generate one or two metrics? Do we have to bifurcate or filter and separate certain subsets of data and create some metrics of how the model performs in certain scenarios to get a more complete picture, right? Because this idea that we can just test the model against all measurement data and come up with some one or two end metrics, where models may perform better in certain sorts of geometry, certain sorts of scenarios, but we don't necessarily do that by default. So if we know there's these things that you're talking about with measurement data that are present in the data, identifying those and then slicing the evaluation of the models to correspond to that or to account for that, and to get those different views can help shed light. Well, why is this model doing better here? Or what's going on? Maybe we have to use two different approaches for different scenarios. I think that does motivate at least that discussion of this.
Yeah.
So I would also say my point wasn't saying that you should have the smallest amount of uncertainty possible in the measurement. It was that you would have to quantify what that uncertainty is. Because Tony's earlier point earlier in the conference was that, or symposium, sorry, was that if you want to compare two numbers, you have to know the uncertainty in those numbers, or you can't actually compare them. And intrinsically, you're right. All data sets have intrinsic dispersion, but that's not necessarily the totality of the uncertainty. And so having the ability to assess that is I would conjecture is important, but I work at NIST, so that's probably why.
Like it just, thank you for that. And I said it many times. I don't know if we got to consensus on it, but I would say that if we didn't make any other points in this conference, or I didn't at least, that clutter is a random process. It's a highly variable process. When we immediately jump to something like the median or the mean, even if the distribution, its underlying distribution was correct, we are leaving so much information on the table, right? And then that, again, builds fear in the person that's ultimately going to try to use the result of the model. So if we're going to make a set of recommendations coming out of here, it's just say no to the median, right? Let's start actually modeling this phenomena and more realistically.
So I'm gonna piggyback off this and be a little contrarian, which it wouldn't be a symposium without me being contrarian. So what can realistically be done to improve the trustworthiness of other people's data? And if you're an entity that has the capacity to collect your own data, do you really care about using anyone else's data to do modeling, to do analysis, because you can you inherently trust your own data more than other people's, because you know how it was set up, you know all ground truth, you know exactly what you're trying to measure, but someone else's, you may have some level of uncertainty that you wouldn't have in your own.
I'll just say that to err is human. And if you trust your own data, you don't know yourself very well, right? I think this idea, and I love this discussion we had this morning. I forget the professor's name that we had. We're talking about, the first thing I want to do if I get a set of data or I think I know something about something is I want to go see if anyone else thinks it too, right? Or I want to see if someone thinks something different. And then I want to ask a question, why didn't we come to the same conclusion? I think, any principled investigator has to ask themselves that question. And if they're willing to, drink their own Kool-Aid is the thing, then that's definitely, if you see somebody doing that, you might want to tap them on the shoulder and say, let's be a little more realistic about this. So sorry.
I also think there's a trust and a psychological and an embarrassment factor that comes into play when, and I've noticed this happening less, but still happening. And what it is when someone comes with their data, to your point, well, I got my own data, I'm going to trust that. Tony addressed that. But what about when someone says, here's my data and here's what it shows, and it is different than your data? As soon as you ask the question, well, how did you collect that? Did you put it on a truck? Did you have a calibrated antenna? It makes them feel like they're being cross-examined in the courtroom, right? And I know that's a little bit of an extreme description, but if there's a way to standardize, and someone brought it up in one of those panels, maybe more than once, about that body of how we did it, the information that goes with every data set. I know it's a pain to do all that, but if you have a non-confrontational way of having that knowledge of how it was actually conducted, did I have a ground plane underneath the probe antenna? Did I have a dent in my horn antenna? I don't. Those are silly examples, but there's lots of things that you could list and say, okay, these are the list of things we should all say how the measurements were taken, right?
You also mentioned how to build trust. Okay, just to give an example, I think. So if I have my own data, you have your own data. If you come to me and say, "Here's, I have this model," okay, and if you apply it to your own data, it fits what you measured. Okay, so that will build me confidence that okay, this works. So you see, so yeah, I think it makes a lot of sense to look at other people's data, try to use that best, and then if you can create models that can take into account and meet all the requirements, that is the ultimate goal here, right?
A different one.
Sure. Go ahead.
So I was really, this morning's discussion about frictionless really got me thinking a couple different things. But the first thing that goes back to my my freshman physics teacher in college is that frictionless is a fiction, right? So there really is no such thing. But the second thing I thought of is like, well, I think about the folks that really try to set up frictionless experiments, and it costs a hell of a lot of money to do that, right? To do that. So I think that the idea is golden, and somebody mentioned it, I think, in the panel this morning as well. But without resources, and without substantial resources to get there, it gets a lot difficult. And so I know every single one of these panels will say we need more money, but I think that some of the things that we're talking about, it's not that we don't know that we want to do them or that we're not aware that they ought to be done, but we struggle. And I know the academic community, as much as anyone, they really struggle with figuring out how to pay for it, right? It's a great idea, but I got to get by my burger at the end of the day, and that's got to take priority. So that's your cue. Go ahead.
I mean, the upside is there is a fair amount of money, right? I think the challenge is to get aligned on how best to spend it and to make the most use out of that investment. So again, we have an NSF-funded center. We're in year 3. We've got 50 researchers, 80 students. How can we put ourselves to work? We want to take more measurements? How expensive is the gear, or can we borrow the gear? Can we come out and take measurements? I think there's ways to, put resources together in ways that we haven't necessarily explored before. And so I think being strategic, being collaborative can go a long way.
Billy, you just got an opportunity to task Spectrum X.
One of the things listening and talk that we've kicked around the halls of ITS a bit is on the measurement side, specifically, is this idea of going the whole way back comment wise, starting with Adrian's comment about if you have data and then it gets it was Adrian, maybe it was Kalle, said it, cross-examined, and you're kind of looking, do you trust other people's data? Is this idea of, having some sort of periodic, and I'm not trying to suggest meetings and stuff like that because nobody wants to go do more stuff, but having some sort of, essentially what it amounts to a calibration board, a workshop where you can bring sensor-based measurement, somebody else can bring a different measurement system, but you have you go in the field, it'd be the equivalent in measurement space as like a code bash or those sorts of things where you say, we're going to bring our measurement systems together. We're going to do some measurements of a single calibrated system. ITS is going to have the transmitter. We're going to transmit the signal in environment. We have different measurement techniques, different systems. We're going to collect the data, and then we're going to take that and we're going to share it. And we're going to say, okay, we have a calibration point. Not all the measurement systems are going to be the same quality. Not all data sets are going to be of the same quality. But you have a calibration point that if you have a $100 sensor and you take part in it and ITS is running theirs, you'll have some calibration. You can then go off in the field. And people say, yeah, but you're doing something with this little SDR. Yeah, but we have some idea of how that relates to something that's, $1 million calibrated. And so now there's this understanding it's not in an isolation. You start to have this like web of kind of scaling. So then you can go off and do other sorts of things with that in different sorts of scenarios, but still have some tie back to the larger ecosystem of measurements, and maybe this is just a once a year, 3-day sort of kind of workshop where you get together and you recalibrate any changes you make and as things evolve and you share ideas. But that could be a way to build trust in measurement data and allow people to kind of come together and then go apart, and you have this kind of heartbeat mechanism. Where both you're sharing new ideas, but you don't have this question, well, I don't trust your data because my system costs more or whatever that is, you know? Because you laugh, but we've heard those arguments, right? Yeah. They exist.
So
I wrote down in a lot of different software communities, they have hackathons. And I think what Billy just talked about is a measurement-a-thon.
Yeah. I think there could be value there if people are willing to participate. I'm not a measurement guy, so this is not me volunteering myself. That's the great thing about me suggesting that.
Good, you're delegating your volunteering. Okay. That's a skill too.
I don't do hardware, so it's okay. It's okay. It's not me.
All right, we'll go to a question.
Yes, hi, I'm Zulfikar Said. I'm from Shared Spectrum. Is it working? Yeah. I'm quite ignorant about how the LiDAR data is collected. And in the first exercise that we had, right, we had the DTM, DSM, and then clutter height, and then you had measurements, right, for the losses. The measurement is not part of the LiDAR, but and another takeaway I had from the conference was that a lot of people said that a building is not pine tree, and pine tree is not a building, so it matters what kind of clutter it is. So can these LiDAR instruments be such that they can identify, like AT&T says they use 24 kinds of different clutters, right, in their model. Can they identify what kind of clutter that pixel is? And that could be done by machine learning or something, and that could be a feature set into your machine learning algorithm that could generate a model because you try to curve fit the model losses that you had based on the clutter heights only, right?
Yeah, so I'm not a GIS expert, but even we within ITS are able to use LiDAR and to differentiate between vegetative clutter and structural clutter.
Okay.
So I can say that at a minimum, yes. At that level, yeah, we can separate that, and we're looking at those sorts of things within our modeling effort. And this gets back to kind of one of my takeaways is I think having some sort of baselining of what's available and bringing in other fields who are even more expert. Because as I've told a couple different people, we are doing this stuff, and I'm the first one to say that we're not experts in this field. We're connecting with other researchers in other areas and other people who are familiar, and we're looking at these things. And if you ask me, we probably have a 90% solution of our understanding of it, and then it kind of becomes diminishing returns. And well, it's good enough at rate for what we're doing right now. I think we would grow collectively to kind of bring in. But yeah, the things such as vegetative and structural, you could definitely kind of look at and start to extract perfect information. I don't know. But there's definitely ways to at least start to pull apart that from the LiDAR data.
Yeah, so if you could have that kind of a LiDAR mechanism analysis, post-processing as part of a conference like this one, that would be very helpful too. And also, AT&T said that they use 24 different kinds of clutter, and they use a model tool called ATOL. So if you could classify them, that would be one less point of argument between modeling communities.
Yeah, one of the things we've thought about doing, going back to the tutorial, is taking what we've thought about and we've explored in the LiDAR space and making it into a Jupyter notebook and into a tutorial, because we're using open source tools to process it. So at ITS, we're not procuring commercial software. Some of the commercial software does a lot more than what we're doing, but we're using open source tools, some of which are being developed, say, like PDAL, who's some of the main, there's some of the people who started that whole project were out of the Army Corps of Engineers Cold Regions Lab up in New Hampshire, Vermont, I think it's New Hampshire. So there's nothing there that's proprietary, and you could conceivably make a tutorial space of, hey, here's how we're doing this. People can engage, and they can contribute back. Again, this idea of, well, I am someone else. I am an expert in GIS, and I'm working with people, and you could improve it by this, and you can essentially, just like you would iterate on a code base, you could iterate on a tutorial, essentially. Maybe that's a point where we can collectively push forward.
Do you know if the current data set has that classification as a feature right at the gathering phase of the data?
with the LiDAR? Is it
Yeah.
being gathered? My understanding of LiDAR, so it doesn't look in the beginning, and we're going down a rabbit hole here, but right, you're looking essentially at intensity of light pulse returns, and then based on that and analysis, you can derive some information from that based on the intensity of those pulses and their angles and everything. But then there's processing on top of that to further derive, because you see depth, you get multiple returns per pulse, and you can start to think about at least just how you interpret that data. We could talk offline, but I think that's one of those points where, right, we can collectively raise the floor of our analysis, kind of talking about those sorts of things.
I'll just add that we work a lot with professional GIS shops early on for doing that. And so even years ago, the standard set of data sets you could get out of our processing raw LiDAR data was you get bare earth in terms of pixels, you get A1 and A2, first return, second return, and you also get extracted building and extracted foliage layers. If you correlate that with some NLCD data, I don't know if you're going to get to 24 what AT&T uses, but even if you just correlate that with the NLCD data that's available now for the USGS, I think you're going to get at least 8 or 9 potentially different types of foliage that you say, well, I've detected that this is a set of trees or bushes, and then I can look at the NLCD data and I can figure out which that is. So I think that's all where we went, but I think it's all readily available today.
So I'm going to go back with a very targeted question. So are you aware of any specific examples where one party that was interested in developing a model used someone else's RF measurement data to develop that model and took that data at face value without doing their own independent measurement to verify the accuracy of that data?
Without verifying it.
I mean, oh, go ahead.
No, I was going to say honestly, the best case and I don't know specifically. If I had to guess, it would probably come from the UK's data set that they've made publicly available from Ofcom's website to download. It's a bunch of different environments, a bunch of different frequencies. I would suspect somebody externally has downloaded that, because that's probably the most comprehensive single data set measurement.
We did.
Okay, well, I'll let Adrian answer it.
Example, we did it at CRC. We used the Ofcom data published on the ITU and then they made available through their own website. And we developed a clutter classification model, which is applied currently by the regulator in Canada. We appended to that some of our own measurements, but we used theirs as well.
So Casey, maybe I didn't fully understand the depth of your question, but I mean, I would argue that anyone that goes to the ITU and pulls down a prop model or a clutter model is tacitly doing what you just suggested. I mean, maybe a few of them are going back and looking at what the contributions were, how that, 452 or 2108 or whatever it was created, but you're trusting that, there was somebody managed to get consensus in the ITU on a model, and that's good enough. That's good enough for me, right? And that is often, whether it's because of resources or whatever, that's often the way it goes. So I would argue that if I understood your question correctly, almost always that's exactly what it is. Very few people go back to the data and say that the measurement data that created this model is consistent with my scenario.
Claire.
Thank you. In mutual appreciation, I'd like to point out that we've been using Billy's data to further develop the ITU models. So yeah, and it's great to hear that so many people are using our data. That's what we're putting out there for, and it's great to get that feedback. Thank you.
Takeaway, you should do more. You should take more. You did such a great job.
Is that why she turned down our panel invite? To be all right, I do want to transition because we've kind of danced around some next steps. But are there any questions online? No? Okay, I always just want to check in and acknowledge folks who are listening in. Let's just pivot and we can take a few minutes answering this last question, and then further questions from the audience. But I'm going to actually reference a plug for this folder. We put a lot of effort into the materials we put in here for folks here. Folks online, go to its.nta.gov. We have our technical progress report in here. Credit to our publications officer, Lily Segre, for putting this beautiful publication together. This details the work that ITS does in this and many different areas. We also have the National Spectrum Strategy in here, which also looks great. But if you notice down here on the inside of the flap, we talk about the mission of ITS to advance innovation in communications technologies, inform spectrum communications policy for the benefit of all stakeholders, and investigate our nation's most pressing telecommunications challenges through research that our ITSers are proud to deliver. With that in mind, advancing, informing, and investigating, what steps can we take? How can we advance and inform as a community here in this pursuit of consensus on clutter, in many of the tangible ways that we've already discussed? But what is your nuggets, your takeaway for the audience to actually contribute and participate and engage in the next steps?
So from my perspective, I'm going to talking about sharing the data, right? Okay. And I think collectively in this room, all the organization here, the data that everyone has is quite a lot, okay? Is just not available to everyone. So small steps, if each of our organization, if we take a small step and try to see what can we share, in what conditions, what will be the limits of that, and try to advance that, I think be quite beneficial. Myself, when I'm going to go home, we have some measurement data, and I'm going to try to explore what are the administrative obstacles from our perspective in order to make that available, same Ofcom and ITS doing it. Thank you.
We've talked a whole bunch about measurements. We've talked a little bit about models. Within that subset of models, we've talked very little about specific models. I think one category of models, the ray tracers, are deserving of some attention in the future. Our ability to characterize environments in excruciating detail is just moving forward by leaps and bounds. What we have available with LiDAR data, with some of these things we talked about, is so much different than it was 10 years ago. And then before that, there wasn't even a lot of LiDAR data. And everybody I guess everybody doesn't remember going through the contour lines in a paper map that was done in 1953 to figure out what your terrain looked like, right? So that evolution of data availability is going to continue. That makes, combined with the speed of the processors of the ray tracers that we heard about in one of the panels, that makes that ability, the depth of the data and availability of the data and the computational capability and accuracy of the evolving ray tracers, a very interesting future way of doing business.
I already said these. My top four things are, if we want to go, the first thing you got to do is we got to separate the technical discussions from the policy discussions. Some policy discussions are difficult, necessarily so, and if we can at least get consensus on the technical part, at least we've removed that, from the equation, and we can just focus on addressing the policy issues, which are hard all by themselves. Number two, reduce friction, provide more resources, do other things, creative things potentially that don't require more resources, but to reduce the friction associated with working through these problems and and collecting data or having these collaborations that you need. Number three, respect the fact that this is a random process, clutter loss. Respect it. Don't try to avoid it and don't try to square it away into a scalar value. And then the last one is, I think this conference represents this, is that we just need to collaborate more. I think we actually sit down and start talking about this stuff. A lot of the things that we think are issues that were barriers to consensus really are ghosts. They're not really there.
So among other things, I think, assuming, is there going to be a workshop report or a symposium report as there has been in the past?
There'll be a synopsis online. Typical.
So I really think trying to collect some of the key resources that are out there, and having, say, quick how-tos in a sort of a more generalized way from what we saw with the tutorial, just educating people of the tools and the data sets that are out there, and giving them some hints, some example scripts of how you would use them. That's something I'd like to take back to our team in Spectrum X. There's a lot of students that I think could get interested in these things, especially if we kind of tell them a little bit more about the why and give them a little bit of a sense of, you know, the scenario, the pictures that we saw in the tutorial, the images, I think are a way to pull students in. So I want to try to compile a brief set of resources and invite more of our team to get involved in this stuff.
You know, one of the things it's making me think of is something that I talked to Lily about a year ago and clearly haven't done in the past year. So I'm a guilty party in this, but aligns with what they're all saying, what we've heard is that we need to collaborate more, but I would say we need to iterate more frequently. And one of the things we talked about, it was a year ago, maybe it was more than a year ago, I don't know. It was a while, is not always waiting until the large publication or the large tech report at ITS to say what we're doing or wait for our findings. But hey, you know what? We're working on a problem and we're going to do it, something we have internally, a tech memo, which is basically, hey, we have this and here's some intermediate results and how we did it. Or she suggested, you know, maybe you just write kind of a long form blog if we're investigating this. And since we're putting data and software available, somebody could pick that up and basically peel back some of the process and don't wait till you get that end result. But hey, I got a promising result and some intermediate thing that this looks interesting, and putting that out there in some sort of forum where, okay, hey, ITS or Notre Dame or whatever, they're only 3 months into some effort, but hey, they see some progress here. It might be a dead end, it very well, and we'll just have to, that's okay, that's part of the process. But being kind of that transparent or working on things, and those are kind of collaboration points at a more frequent interval as opposed to, well, I have to wait till I finish the work and then I write the report and then there's the conference. Let's be honest, at least from my experience, by the time you get to that, many times the funding's gone and you're not going back to do more. You have to rewrite the proposal. So perhaps kind of some form of kind of communication and I know all that is, we're all probably thinking that just sounds like more work during the process. So it's not necessarily fun, but I think that would be a way to kind of iterate quicker and share information in a way that there is that ability to collaborate instead of waiting till the final publication to identify where it is. So I don't know, that's kind of what came to my mind while everyone here was talking on this subject.
Great. All right, let's sort out for questions one last time on any or all of the above. And I might pose a question to the audience to spur some engagement. You could do that as well, not that it'll be successful. Okay, the next thing I'm going to say is, who wants to take the mic from Casey? Go ahead.
So, what are the 3 to 5 most important metrics when it comes to assessing the quote unquote goodness of a model?
Okay, 3. Let's say 2 to 3.
Really only one. How well does it predict what I needed to predict? You asked me for a metric. You didn't ask me how to produce it. But you know I can go on about that as well. But at the end of the day, when we do our error functions, as we said, here's what we were trying to get. What did we get? How good was this model? And if you want to properly calculate that, as we talked about in our panel, within the context of the parent model, because you can get RMS or whatever. It's like, well, that's great, but how did you do your M? If it wasn't in the context of the parent model, then it's not that useful, right? So you take it in mind what your parent model is, get your prediction, and then you just measure your error. I mean, that's ultimately, maybe you want to bound the error. I don't know. It seems like you're fishing for something. I'm not sure what. I'm sorry, Casey. I'm just let Casey answer the question. Kalle.
I've got a top 4. Validation, 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 and validation. If you've got that, I don't care how you create that model. If it can sustain a thorough validation and with the kind of use cases that you believe in, and with a sufficient number of samples or whatever your metric is to make it reliable, you know. I don't care how it's done.
All right, I'll provide a plugin for the study group 3 discussions last week. So what we've been discussed there may be good performance metrics to evaluate how good the model is versus other, assuming that you have a reference data that you're comparing with. So it's mean error, root mean square error, standard deviation, and linear correlation factor. Right, those are the ones which have been discussed, and I mean, probably you need some or all of them, depends on what exactly. Thank you.
You have a question? Any questions online?
Yeah, I'll bite.
You do have a question. Okay.
So, yeah, you mentioned that obviously policy is fun, let's just say, when it comes to some of these things. And I think most of us can agree. There's probably a reason policy people are at these synopsises, conferences, all the above. Kind of trying to keep the technical and the policy separate. How do we still address like the chicken or the egg part of it, right? So oftentimes policy won't issue something without a technical result, but often that technical result won't happen because maybe private might need some sort of return on investment in the long run of it. Is it incentive based? Do you see more like error margins and policy makeup down the road, or how do we address that situation of it?
We didn't prep policy questions, did we?
No, you didn't.
Yeah, when we've run across it, it's, I mean, it's, you just have to look at what your scenario is and look at your best way forward is. In the NSS, there was a lot of discussion, and I think it's extremely important that we're only going to do fact-based, scientific-based stuff. And so if you get into a discussion with policymakers, for what other reason, I think if you continue to sort of highlight that this is, foundationally, this is where we want to start, and not to prejudice anything that you're going to do with that, but let's not let the policy prejudice the science, right? Let's get as close to the actual answer for the technical question, and then let the dog wag the tail, so to speak, or the tail wag the dog, I guess is what I should have said. So I don't know. I think it gives you scenario by scenario. It really depends on who your policymakers are, how flexible they are. If they already know the answer, it really doesn't matter what technical you give them. That's what's going to be, right? That doesn't happen that often, I don't think, but I'm sure it actually, in some cases, it does. So, anyone else?
Yeah, I see. Derek has an answer to that question. I'm just kidding.
I might.
I just wanted to mention though briefly where Derek and Ira had that conversation in the fireside chat Wednesday. So I encourage you to go back and listen once the session recordings come out. But honestly, sitting next to those two, having them talk about we want to be enablers, I'll paraphrase, but set everyone else up for success with equal opportunity. And I know coming from ITS's perspective, we want to be objective, independent, trustworthy, and agnostic to who we're looking at or working with or what technology we have in the lab. So just setting folks up for success and then the highest, best use of a finite resource is what I heard from that panel. So that was good to hear. Nick?
I was just going to suggest.
There we go. I was just going to suggest that there might be a third component instead of just a chicken and egg and what's going to cause and create the pull. Just the pursuit of better understanding, right? Research in general can help fill in some of those gaps and maybe instigate that loop from one dimension or another.
I wanted to take it from another. One of the speakers came up, I think he was from T-Mobile, and he put up a BDC map on the wall. And BDC is the broadband data collection requirement of the FCC for coverage. And whether you're served or you're unserved. And it goes to NTIA's IIJA NOFO because that's the data that they're using for that. So when we're looking at that kind of heat map basically, and trying to figure clutter into that, because if you don't, then what are you really covering? And three of you up there said results, results, results. That's all I want. But clearly those results are wrong because those buildings are not being served. There's no way millimeter wave is going into those buildings in the fashion in which that heat map shows. How do we get the data that we're collecting to go with the mission that we're serving? The mission of BDC is to say, hey, are Americans getting broadband? And we're trying to do this with a mapped version of that, and it's inaccurate. And then the only answer that they have for that is we have a challenge process. But in the requirements for BDC, there's no standardization of what clutter is. There's no standardization of how the reporting is. There's only characteristics of reporting. So we get an inaccurate map. 3 months ago, we supposedly had 13.3 million less people who were uncovered than we do in the recent round. I don't, statistically, that makes no sense whatsoever. So how do we get to that validation point? How do we improve what we're doing, not just on an academic level, but in the sense of drawing it to the thing that we're really trying to do?
I'll take a stab at something I have no idea about, and I only learned it existed 24 hours ago. But to speak generally of it, I would say transparency in the methodology, it would be the first step. So maybe some of this is out there, but if you're completely transparent on exactly what of those hexagons were colored and which were not, and what was considered, then at least it allows, okay, if we think it's wrong, why can be it wrong? And then having some sort of feedback loop, I'm not saying a challenge thing in the sense of how can you improve the methodology? Let that iterate, because if you have, again, speaking broadly, if you could explain the entire process transparently, what's going on, what are the assumptions, how are you coming about this? And then you allow people to provide feedback, and they could go take measurements to show, no, because you're not considering this, look at this. Then you have some method to kind of iterate closer and closer to a better, an improved solution. If the methodology isn't explained exactly how you're coming up with the result, then I'm not sure as an engineer, struggle to interpret what I'm looking at and how you got there, right? Because there's many, many different ways. And so I don't even know how to engage in that respect. So I guess, again, speaking broadly, because I only learned that existed yesterday, that would be my initial comment on it.
I'm not sure I know exactly, I don't know the history of all that, but the description I heard from you makes me think that the user of a model or the results of a model shouldn't be responsible for validating that model, right? It's the creator of the model who should bear that burden. And how well they do that has a lot to do with some of the things we were just talking about, documenting the methods and whatnot. But I mean, to me, just expecting the user to validate the model that they're being used or was created by somebody else is like cleaning your house before the housekeeper gets there, so they don't have to work too hard. I mean, we've got to kind of allocate responsibility there. That's probably a lame response, but insightful.
Would the challenge process not work? I mean, I'm not sure how that goes.
No.
The problem with the challenge process is it's just as inconsistent as because there's three levels of challenge. You can be an industry challenge, you can be an individual challenge, and you can be a challenge from within the industry itself. And there's no metric that says you're just challenging it to say the data's wrong. They're not really covered. And then that entity has to prove that they are.
Right.
And that's a problematic way of doing things.
Yeah.
All right.
I might suggest more engineers get involved in the process. It sounds very legal.
Well, oddly, you should.
I mean, all due respect.
Richard, nobody can hear you online. So we have time for like one question more. We do have one. There you go. I couldn't see the mic in your hand. There you go.
You can't
I
hide
don't
from
know
us.
where it's at.
You got it.
Hi, this is Rich Lee. For this panel, I think we've made a lot of progress, whether you're a model or a measurement focused or based. Should I move over? Whether you're in the measurement camp or the model camp, on cases where it's a dominant path, it's a single dominant interference case. I'm taking us into the spectrum sharing. How would you guys look at it if you have aggregate interference, where there's more than one, there's 3, there's 5, there's 10 potential contributors to interference in the DSS use case?
Can you repeat that question too? As you understand it.
I think the question, I guess folks aligned it in Rich, but just to restate it, is like when drawing on the sort of the baseline that we had in our how to properly use clutter models in our panels. Like, what if your problem is an aggregate problem, not a point-to-point or a single problem? That's really what you're going at, right? And so my first answer to that is just to echo what one of my first slides said when we started off our panel is you always start with the objective model. And the objective model, I mean, I get that sign prove me wrong thing. The objective model is never the clutter model. The objective model is some other model. And if it's an aggregate model, then you got to start there and you got to make sure that the clutter model you use is properly influencing the parent model, the aggregate interference model. And if you don't have that, well, then you need to get a different clutter model, right? I mean, you need to figure out how to take that square peg model you have, put it into the round hole of an aggregate analysis. And there are standard techniques for doing that. We've done it hundreds of times in different ways. Typically, being someone that generally works with the DoD and some of their analysis, that's almost always our problem, right? We have an aggregate problem, right? So that's what we do. So.
It depends also on the problem itself. For example, if you talk about aggregating interference, if all the systems and their locations are known, then a detailed analysis can be compiled. So we're talking a lot right now, the expanding cloud computing, storage and capabilities related to the data. That is also valid in relation to computing. So there are packages and capabilities for large-scale geospatial analytics right now that can do analysis at very large scale with many large number of interferers and victims and do a comprehensive analysis, including all the possible impacts, right? Co-channel, adjacent channel, in-band, out-of-band interference, everything. It can be modeled. It's just a matter of putting the right models in there and then running it is not the problem. Opposite to that, if full information is not known, so maybe the victim locations or positions or times are not, or the interference ones, then you're pushed back to some kind of Monte Carlo type of analysis and so forth, and you might want to have some assumptions on aggregation factors and things like that, right? Yeah.
Any last comments? Insights? Or questions? I think that was just about it. We can wrap. Thank you for, first of all, moderating the panels and putting the work into organizing those and for the content and all that you did, and also for this wrap-up panel. I thought this was a good way to summarize, but also have something in addition on the last afternoon to take away from ISART. So thank you very much. So I will ask you to just hold there and stay seated. I will just give some final remarks, putting on the MC hat again. A conference like this, as most of you know, takes a lot of effort and a lot of folks. It's a team effort. As you know, a lot of resources go into this. So I do want to thank our co-technical chairs, once again, Charles Dietlein and Billy Kozma. Thank you so much for your leadership and all the effort you put into this. It is very much appreciated, and I do hope that in a year or two, you'll think about doing another one. Maybe 3 years. I also want to thank our technical program committee, Mike Cotton, who I should have mentioned at the beginning, but he's under the weather and was not able to join us in person. We miss you, Mike, but thank you for your help and your leadership in corralling all of us. Sometimes some first time ISARTers, that's a term, including myself. Also, Nick Lanneman, Casey Pugh, who you heard from today, and Needy Tandon, who might still be in the audience. Thank you so much for giving your time and knowledge and expertise, and also your Rolodex to ISART. Really appreciate it. And I should also mention our NTIA leadership who work here in person and behind the scenes to support this symposium, including Charles Cooper, Shiva Goel, who spoke on the kickoff day, and Derek Clopin. Thank you so much. Specifically, all of our speakers, thank you for coming out, and moderators. There's an ITS team working behind the scenes. Lila Segre, Elizabeth Manis are the folks supporting us in IT and AV. Thank you so much. I always want to say thank you to the AV team, because even though there are hiccups due to clutter in some circumstances, thank you so much for your efforts. Can we give a round of applause to the AV team? Okay. Thank you so much. We have gotten some questions about the slides. We will be sharing slides, and along with that, you'll see them in an email that will point you to the direction of where to retrieve them. We also want to ask for feedback on this year's symposium. As I mentioned at the kickoff, this is our first hybrid symposium. It's our first symposium with an in-person element since COVID. Don't be too harsh, but tell us how we did. Constructive feedback, positives are always nice to hear, but what would you like to see in a future ISART? Topics often change and rotate, but let us know what you're interested in, what worked well, what did not, and what you found most valuable. We are in some manner or fashion going to put out a few questions to you all when we do share the slides for that feedback. But again, you can always just check out the back of your agenda and see ITS's email address here, itsinfo@ntia.gov, and please let us know there what you think. It was an honor to serve as general chair this year. I want to acknowledge I stand on the shoulders of giants, and we are missing Rebecca Dortch. She did retire, and so she was not here today, but I am very honored to be able to serve in this role. So thank you to all of our team who pulled this together. I think you did a great job, and this was... Oh, all right. Appreciate it. Thank you, Derek. Okay, I think those are all the notes, and I'm sorry for holding you for another minute, but that was important. Thank you all for coming out, and Lily has her hand up. All right, we do have an opportunity for y'all to, and I mentioned it before, but we have an hour and a half. Please don't run out. Catch the lightning in a bottle because there's a lot of expertise here, a lot of good ideas. And even after 3 days, maybe we'll all celebrate for a little while in the hallway. There are refreshments available. There are snacks as well. So please enjoy the social hour and a half out in the hallway. If I forgot anything, I apologize. We'll email you about it. Thank you all very much, and safe travels home.